Alright, and now we're coming to the end of this lesson. So there's two things that I want to do here. One, a little bit of math, and I hope that a lot of you already know how to do some of this because we're looking at scientific notation, and you should know how to do some scientific notation. We've talked about it in class, and this is just a nice little easy thing. So if you got a pencil handy, follow along, see if you can do it without my help, but obviously I'm going to show you the answers. And then some really good help on the next concept map, which of course is going to be your test. Okay, I guess I should read this to you. Numbers that refer to the ages of Earth's fossils are very large, so scientists use scientific notation to work with them. For example, mammals appeared on Earth about 200 million years ago. Or you can see, we can write it like this, which is pretty easy, or 200 million years ago. Change the numbers to scientific notation the following process. Move the decimal point. Okay, do you see the decimal point? Of course not. The way we do it with whole numbers is if you don't have anything showing, the decimal is invisible. It's right there at the end of the number. So you have to pretend it's there. So move the decimal point until only one non-zero digit remains to the left. So we took the decimal from here, we moved it all the way over there, and we have 2.1234567 zeros. Okay? And so you just change it to 2.0 times 10 to the 8th years. That's how you do scientific notation. Now we get to practice a little bit. The first vertebrates appeared on Earth about 490 million years ago. Express this in scientific notation. Alright, let's first write down the number. There's 490 million. We're going to count the spaces. You ready? 1, 2, 3. Are you counting with me? 4, 5, 6, 7, 8, 8 spaces. Okay, I did something wrong. I think that needs to be shifted over a bit because the last arrow should have ended up right there. It is 8 spaces. 1, 2, 3, 4, 5, 6, 7, 8. I'm good at editing. I could edit this out. But then again, you knowing that I can make mistakes maybe makes you not feel so bad about you making some. So we're just going to keep going. So we know that it's going to be 10 to the 8th. I have a 4 and a 9. So it's 4.9 times 10 to the 8th. Can you do scientific notation? Here's your practice. You get 3 problems. You have 45.701, 0.00042, and 2.5. Okay, I'll wait. Convert them to scientific notation. You should do it. You should do it now. You should pause the video and not wait for the answers and see if you know how to do it. Do the scientific notation. I'm scary when I'm this close to the camera. Okay, you've paused, you've done your best. Let's see how you did. You just let it run, didn't you? Wait till you get back here. We'll fix all this. Okay, so the first thing, well, let's see. I think I just wrote the whole thing down. 4.701, we have to move the decimal just one place to the left, so we get 4.5701 times 10 to the first. Pretty easy. With this one, we have to move it 1, 2, 3, 4 places. But in this time, we went to the right. So if we move to the right, we're going to have a negative exponent. So that's going to give me 4.2 times 10 to the negative 4th. How you doing so far? Are you getting it? Send me emails if not. Okay, finally 2.5. But Mr. C, the decimal's already in the right spot. What do? Good question. It becomes 2.5 times 10 to the 0. because 10 to the 0 is 1, and you multiply 2.5 times 1 and you get 2.5. Scientific notations. It's really cool. Thanks for watching, and I hope that you can now solve problems like this. There might be a quiz on scientific notation coming up at some point. Of course, it still makes it really hard because you can find all kinds of resources and figure out ways to answer because you're out there and not here where I can watch you. So it's your brain. Make it strong. Make it good. You can do it. You want help with the concept map? Okay, here we go. Ta-da! I'm going to zoom the camera a little bit. I'm going to adjust the camera a little so that you can see that better. And I'm even going to make the lighting better for you because I know what you're doing at this point. Some of you have already taken out your phones and you've taken a picture of this. Or maybe if you're watching it on your phone, you've done a screenshot of this. And that's okay with me. What I want you to do is to understand the connections, because this is what I've been teaching you about, and it includes me making yet another mistake. Alright, so I'm still here. I can't see myself. There we go. And here's the concept map. Why did I use evolution as my starting word? Well, the title of the chapter is The Environment and Change Over Time, which you could put right there. But since evolution is eventually going to be one of your vocabulary words, and since I know that that's what that means, I went ahead and put evolution in there. Make sense? Alright, then I said evolution is reinforced by the fossil record, which we talked about. And then we decided there were 6 fossil types. No, we didn't. I only showed you 4 fossil types. I skipped 2 back at the beginning of the chapter. And that's crazy because I have all these samples sitting out here of fossils. See? Fossil. And these are mineralized. These have had the bone that's in them changed and replaced with minerals. And we didn't even talk about this kind of fossil. And as far as I know, it's the most common. So that's why I put mineralization in. You can also get fossils that leave a layer of carbon behind. That's where coal comes from. It's carbonization. And so the 6 types we have are mineralization, carbonization, molds, casts, trace fossils, and preserved remains. Now these 4 we did talk about. That's why they're in blue. The 2 purple ones are the new ones that we haven't talked about, but the book has it in it, and if you're reading the book, then you know that. Then I also wrote the fossil record reveals biological evolution. Evolution can lead to extinctions, and then I added that there's 5 mass extinctions that we just talked about. And finally, because, I want to get more points, so I made it neat. I've got all kinds of nice little lines and all connections, and I figured why not add a few definitions. Since I get molds and casts confused, I put those in. The impression of an organism in a rock is called a mold. A cast is a fossil copy of an organism in a rock. Trace fossils are the preserved evidence of the activity of an organism. And preserved remains, the original tissue of an organism. Of course, I don't have definitions for mineralization or carbonization, but you can add that. So that takes care of lesson 1. That's how to do the concept map and start your concept map. And that's going to be your test. And I've made it pretty easy for you to begin, right? You're welcome. When we come back, there's going to be a pretty cool video that, well, you get to watch the video. We won't watch it here, but it's really cool. It's called the Jeff Corwin Experience, and he goes to the Galapagos Islands. But that's in the next lesson.